Let's talk about plausibility in science. Science is a cumulative effort, which means that every idea we come up with in science, because it's describing the same reality, the same universe, must agree internally. It must agree with itself. Therefore, as we build an ever more sophisticated model of how the universe works, we can use that model, those ideas that have panned out, in order to test the plausibility of any new ideas in science. It gives us a starting point, or a point where we begin new sets of experiments based on the principles of plausibility, so that we can avoid having to redo the limitless number of experiments that would otherwise be required. It gives us a place to start. So how do you determine prior plausibility? One way is to look at the best, strongest evidence for a given topic. Is the new claim in line with that evidence? If it is, then prior plausibility is high, and the threshold of evidence is therefore lower for this claim, even though it still may be incorrect. Does the new claim disagree with the current accepted body of evidence? Prior plausibility is then lower, which brings us to the old axiom: extraordinary claims require extraordinary evidence. The evidence for the claim must be at least as great as all of the previous evidence that says that it shouldn't be true or that it's highly implausible. So you're still comparing evidence to evidence. A really good example of applying the idea of plausibility to an idea can be demonstrated with homeopathy. Homeopathy, as many of you already know, is the belief that by diluting something in water enough you can get some type of medicinal effect out of it. There is nothing in science today that would suggest that homeopathy would be plausible. There is no way that we can see so far with our current science to prove homeopathy, or even give it a mechanism for it to work in the way that it's described. Therefore, we would say that homeopathy is an extraordinary claim. Water that doesn't have any active ingredient left in it cannot have a complex chemical action. For example, homeopaths would try to rescue the plausibility by saying that the water retains the memory of what was diluted in it. But that's replacing one form of magic with another, because there's no mechanism for the water to have a fucking memory. Or to retain it as it gets put onto a sugar pill and then eaten, digested, absorbed into the bloodstream. Then you're trying to say that this water is still holding together enough memory to have a physiological effect. What the fuck? It's so implausible that from a practical point of view we could say that the probability that homeopathy can work is as close to zero as we can have in science. Of course, though, it's important to keep in mind that plausibility or implausibility in and of itself is not enough to debunk or to confirm an idea. It's just a sniff test to give you the heads up that maybe something needs to be investigated further. So with homeopathy, we would need a mountain of evidence that it worked. It would have to have a very clear effect. It would have to be reproducible, statistically significant, and have a large physiological effect, so that nobody could doubt that there was some effect happening. Then we would go back and say there was obviously something wrong with our plausibility argument. There must be some new effect in nature that we haven't discovered before. That's fine, as long as the evidence for a new effect, requiring us to rewrite the physics or chemistry textbook, is equal to the evidence that says it shouldn't be possible in the first place. So, plausibility plays an absolutely essential role in science. Without the consideration of prior plausibility, it's as if we're starting from square one with every new thought or idea that people come up with. And that all of that goes utterly against the cumulative nature of science.